James Webb Space Telescope just found stuff in space that will blow your mind. We're talking galaxies that shouldn't exist, stars powered by dark matter, and areas where time goes backwards. You won't believe what scientists are seeing. Stick around, because the universe is way crazier than we ever imagined. When the James Webb Space Telescope launched in late 2021, no one could have predicted just how dramatically it would rewrite the story of our universe. For decades, scientists believed we had a solid grasp of how the cosmos was born, how stars formed, and how galaxies evolved. But in just a short time, Webb has shattered those long-held assumptions and forced even the most confident astronomers to question the very foundations of modern physics. Orbiting nearly 1 million miles from Earth, far beyond the interference of our planet's atmosphere, the James Webb Telescope sees the universe in infrared light, a wavelength invisible to human eyes, but perfect for peering through dust clouds and reaching back in time to the dawn of creation. Every image it sends home isn't just beautiful. It's a data-rich time capsule revealing events that happened billions of years ago. And what Webb has found is nothing short of astonishing. From galaxies that formed impossibly early to signs of strange cosmic structures that defy explanation, the telescope has shown us a universe far more complex and far less predictable than anyone imagined. Scientists who once thought they were closing in on the ultimate theory of everything are now saying we may be on the edge of a crisis in physics. Why? Because Webb isn't confirming what textbooks predicted, it's breaking them. Each new observation seems to contradict established cosmological models. Galaxies are appearing where there should be none. Stars are forming faster than our theories allow. Even the chemical fingerprints of distant worlds hint at processes we can't yet explain. This isn't just a leap forward, it's a paradigm shift. Webb has become more than a telescope. It's a cosmic truth machine exposing how little we really know. Every beam of ancient light it captures reminds us that the universe still holds secrets deep enough to rewrite science itself. And as we stand on the edge of discovery, one question echoes louder than ever. If our models of the cosmos are wrong, what else about reality might be too? It began as a faint whisper in the cosmos, signals so subtle most telescopes would have missed them entirely. But the James Webb Space Telescope doesn't just see deeper into space. It sees further back in time, into the very first moments after the Big Bang. And buried within that ancient light, astronomers noticed something that didn't belong. In mid-2023, a team of astrophysicists studying Webb's deep-field images discovered 3 peculiar galaxies unlike anything ever observed. Their light signatures didn't match any known pattern of star formation. The glow wasn't powered by nuclear fusion, the process that fuels every star we know, but by something far more mysterious. That's when the term dark stars entered the conversation. Before we dive in, hit that subscribe button and turn on notifications. We're uncovering the craziest secrets of the universe. Also, drop a comment below telling us which discovery blew your mind the most. Dark stars, time-reversing galaxies, or the mysterious unknown entity? These theoretical objects, once dismissed as pure speculation, might be real after all, powered not by heat and pressure, but by dark matter, the invisible substance that makes up about 85% of the universe. These giants could have formed in the earliest ages of cosmic history. Imagine stars hundreds, even thousands of times larger than our Sun, glowing faintly with the energy released as dark matter particles annihilate within their cores. If this is true, then dark stars could be the missing link behind one of the universe's greatest mysteries, the origin of supermassive black holes. For years, scientists have struggled to explain how such enormous black holes appeared so quickly after the Big Bang. But if dark stars existed, their eventual collapse could have seeded these ancient cosmic monsters, giving rise to the massive black holes now seen at the centers of galaxies across the universe. Yet, there's something deeply unsettling about this discovery. We still don't know what dark matter is, how it behaves, or why it dominates the universe while remaining completely invisible to us. If dark stars truly exist, it means entire generations of cosmic giants lived and died in total secrecy, unseen until now. The James Webb Telescope has done more than detect ancient light. It may have uncovered an entirely new form of stellar evolution, one powered by forces we barely comprehend. For the first time, humanity is staring into the dark heart of creation itself, and realizing that the story of stars, and perhaps life itself, may have begun not in fire, but in shadow. About 48 light-years from Earth, orbiting a faint red dwarf star, lies a world that could change everything we know about life in the universe. Its name is JWST, a planet once dismissed as just another super-Earth. But when the James Webb Space Telescope turned its golden mirrors toward it, what it found stunned scientists around the world. JWST isn't a rocky planet like Earth, nor a gas giant like Jupiter. It's something entirely different, a water world, cloaked in a dense atmosphere, rich with water vapor and methane. Webb's infrared eyes pierced through the planet's hazy clouds, revealing signs of a massive, steaming ocean that may span the entire planet's surface. Imagine a world where the sky glows deep red under a dim star, and endless oceans stretch in every direction. Beneath its thick, humid atmosphere, JWST could be teeming with exotic chemistry, and possibly the early ingredients for life itself. What makes this discovery so groundbreaking isn't just the presence of water vapor, but how much of it there is. Webb's instruments detected molecular patterns that point to an atmosphere unlike any we've ever seen before. A perfect mix for prebiotic chemistry, where complex molecules might begin to form. Scientists now believe JWST might be a key to understanding how life begins, not just on Earth, but across the galaxy. It's a living laboratory for the origins of habitability, a window into how planets evolve when covered by endless oceans and wrapped in heat-trapping gases. And yet, this world also defies our expectations. Its surface temperatures may soar above the boiling point of water, creating conditions closer to a colossal pressure cooker than a calm blue planet. But even in such extremes, the chemistry for life could thrive, not as we know it, but in ways we've never imagined. With every new observation, the James Webb Telescope is painting a clearer picture of JWST. It's not just finding a planet, it's uncovering a possible bridge between lifeless worlds and living ones. If JWST is truly an ocean planet, then it may prove one thing beyond doubt. The universe doesn't just make room for life, it creates it. In the silent reaches of the cosmos, James Webb's golden mirrors captured a whisper from a time long before our world even existed, a faint signature of something extraordinary. Hidden in the light of a galaxy over 12 billion years old, scientists detected a pattern unlike anything expected from such an ancient corner of the universe. What Webb had found were polycyclic aromatic hydrocarbons, complex organic molecules, the very same building blocks of life found in living cells, meteorites, and even the smoke from a burning candle. This discovery sent shockwaves through the scientific community. Until now, most astronomers believed that such intricate carbon-based molecules could only form after generations of stars had lived and died, enriching space with heavy elements. But Webb's data told a different story, that life's ingredients were already present when the universe was still in its infancy. Think about that for a moment. Billions of years before Earth took shape, before the Sun even existed, the chemistry that would one day give rise to DNA, proteins, and living creatures was already at work in the distant galaxies. The implications are staggering. It suggests that the universe began preparing the recipe for life almost immediately after it was born. If these organic molecules were forming just a billion years after the Big Bang, then the processes that lead to biology might be woven into the very fabric of the cosmos itself. What's even more mysterious is how these molecules could survive in such a young and violent universe. Back then, galaxies were chaotic, filled with radiation, newborn stars, and swirling clouds of gas. Yet somehow, carbon-based compounds managed to form and endure, hinting at a cosmic resilience that defies explanation. For scientists, this means the timeline for life's potential has just been pushed back by billions of years. And for everyone else, it poses a haunting possibility. Maybe life didn't begin on Earth at all. Maybe it's a cosmic inheritance, seeded by ancient galaxies that thrived long before our solar system was born. As Webb continues to look deeper into time, each new discovery feels less like the story of stars and more like the story of us. The universe, it seems, was creating the chemistry for life not as an accident, but as a natural part of its own evolution. When the first deep-field images from the James Webb Space Telescope were released, astronomers expected to see faint, fuzzy glimmers, the earliest, smallest galaxies forming in a young, chaotic universe. But instead, they saw giants, massive, fully developed galaxies shining brightly just 600 million years after the Big Bang. And that discovery changed everything. These weren't tiny clusters of stars struggling to form. They were immense, organized systems, some as large as the Milky Way, appearing at a time when, according to every cosmological model, such galaxies shouldn't even exist yet. Webb wasn't just peering into the past. It was staring directly into a cosmic paradox. The data was so shocking that many scientists thought it had to be a mistake. Maybe Webb's instruments were misreading the light. Maybe the galaxies weren't actually that old. But after months of careful reanalysis, the conclusion remained. The universe built its first massive galaxies far faster than anyone thought possible. To understand how strange this is, imagine the universe as a baby, less than 1 billion years old, already hosting fully grown adult galaxies. For this to happen, matter would have needed to clump, collapse, and ignite into stars with lightning speed, breaking nearly every rule in our understanding of physics and cosmic evolution. Even more confusing, these ancient galaxies aren't just big, they're mature. Their light shows signs of heavy elements like carbon, oxygen, and iron, meaning generations of stars must have lived and died to create them. But how could so much stellar evolution occur in just a few 100 million years? Some scientists now whisper that our entire model of the early universe may need rewriting. Perhaps the Big Bang unfolded differently than we think. Perhaps dark matter, or something even stranger, accelerated the birth of structure. Or maybe, as some daring theorists suggest, we're seeing evidence of an earlier cosmic cycle, a universe older than we've ever imagined. What's certain is this: the James Webb Telescope has forced humanity to look at the universe with new eyes. The cosmos is not the slow, steady builder we thought it was. It's wild, explosive, and unpredictable, capable of creating entire galaxies long before the laws of physics said it could. And as Webb continues to look deeper into the darkness, one question grows louder with every discovery. If our universe can create the impossible, what else might it be hiding? In the vast, silent darkness of deep space, the James Webb Telescope captured something so strange, so precise, that it left even the most grounded scientists speechless. A galaxy that seemed to mirror itself. A perfect, symmetrical spiral reflected across the fabric of space, as if the universe were showing us its own reflection. At first, astronomers thought it had to be an optical illusion, perhaps a gravitational lens bending light from a distant galaxy into a symmetrical shape. But Webb's instruments are the most advanced ever built, and when the data came back, it told a story no one was prepared for. This wasn't one galaxy split by a trick of gravity. It was two, identical in every measurable way, down to their star formations, dust clouds, and spiral arms. The odds of such perfect duplication are beyond astronomical. And that's when a radical idea emerged. What if this is a cosmic echo, a ripple through space and time, revealing that our universe might not be alone? Some physicists now believe Webb may have stumbled upon the first tangible hint of a multiverse, parallel realities coexisting just beyond our perception, each with its own version of space, time, and physical laws. In this theory, the mirror galaxy could be a kind of resonance between two universes, a point where their fabrics briefly overlap, allowing light to leak from one into another. If true, this discovery would shatter everything we think we know about reality. The idea that there could be other universes, perhaps countless ones, where galaxies, stars, and even versions of ourselves exist, has long been the stuff of science fiction. But now, Webb's precision data has turned that fantasy into a scientific question that can no longer be ignored. Even more unsettling is how precise this mirror symmetry appears. It's not chaotic or distorted. It's elegant, mathematical, almost intentional, as if the universe itself is built upon some hidden geometric order, repeating across multiple realities like the reflections of an endless hall of cosmic mirrors. Could this be evidence that our cosmos is just one of many? Could light itself be crossing the borders of universes, giving us a fleeting glimpse of the infinite? Whatever the answer, the James Webb Telescope has once again pulled back the curtain on something far bigger than we ever imagined. It's not just revealing what's out there, it's challenging the very concept of what out there means. As we stare into the mirrored spirals of this mysterious galaxy, we may be looking not just into space, but into another universe staring right back at us. In early 2024, deep in a region of the universe 15,000 light-years away, the James Webb Space Telescope captured something no one expected: a heartbeat. Not the thumping of a human heart, but a rhythmic pulse of light and energy coming from a dying star in its final moments. It wasn't random. It wasn't chaotic. It was structured, repeating at precise intervals, like the steady rhythm of a coded message echoing through space. At first, scientists thought it might be a pulsar, a neutron star sending out beams of radiation as it spins. But Webb's data didn't match that pattern. This signal wasn't spinning. It was breathing, expanding and contracting with perfect regularity. Each pulse carried subtle variations in brightness and wavelength, small shifts that seemed to form a mathematical sequence. Something in this star's collapse was producing an organized signal, almost as if the cosmos itself were trying to speak. They named it the Heartbeat Star. When Webb trained its instruments for a second observation, the phenomenon intensified. The pulses became more complex, layering frequencies in ways no natural process had ever shown before. The light curve resembled the structure of sound, a rising and falling tone encoded in the electromagnetic spectrum. Was it simply physics behaving in a way we've never seen? Or was it something more? Something intelligent woven into the death cry of a star? Astrophysicists have proposed several theories. Some believe these patterns could be a new kind of stellar instability, revealing how stars collapse into neutron cores or black holes. Others whisper about something stranger, that perhaps the heartbeat represents a cosmic language, a form of resonance written into the laws of the universe itself. And then there are those who take it further still, wondering if this might be an artificial signal, deliberately embedded within the rhythm of the dying star, waiting for a civilization advanced enough to notice. Of course, there's no proof of that. Not yet, but as Webb continues to record these luminous beats, the data grows stranger. The timing is too perfect, the patterns too deliberate, like a cosmic Morse code pulsing from the edge of eternity. If it's natural, it's a discovery that could redefine stellar physics forever. If it's not, then the universe may have just spoken to us for the first time. And perhaps, in the fading light of a dying star, humanity has begun to hear the heartbeat of creation itself. In late 2024, deep within NASA's high-security data center, an artificial intelligence designed to analyze James Webb Telescope data made a discovery that left scientists both awestruck and uneasy. The AI, trained to detect patterns in deep space gravitational maps, was scanning one of the largest voids in the known universe, a region of almost complete emptiness, billions of light-years across. And then, it found something Buried within that silent expanse, the system flagged a gravitational spiral pattern, a swirling distortion in space-time itself. It wasn't a galaxy, a star, or even a black hole. It was something else, something moving. The AI's algorithms struggled to classify it, running through every known category of cosmic structure, and coming up empty. After hours of recursive analysis, it labeled the phenomenon with just two chilling words: unknown entity. At first, researchers thought it was a glitch, maybe a software anomaly or a data artifact. But when they reprocessed the Webb imagery, the spiral distortion was still there, consistent across multiple wavelengths. It wasn't a mistake. Something inside that void was bending gravity in ways that defied every known law of physics. Whatever it was, it didn't emit light. It didn't absorb it either. It simply warped space, like an invisible hand stirring the cosmic fabric. The pattern rotated slowly, generating ripples that echoed across the surrounding void, almost like gravitational waves. But with a frequency unlike anything ever detected, the AI began mapping the behavior, predicting its movement, and found something even more unsettling. The spiral appeared to be self-organizing, maintaining a perfect geometric form as if it were following an internal logic or purpose. Each loop of the spiral was mathematically precise, almost engineered. When scientists overlaid the data with cosmic background radiation, they noticed faint distortions extending outward, as if the entity was drawing energy from the very structure of space-time itself. Some called it a natural anomaly, maybe a new kind of dark matter vortex. Others weren't so sure. What if this wasn't random? What if this was intentional? A gravitational construct created by something we can't yet comprehend. NASA has not released the raw data to the public. What we know comes from anonymous insiders claiming the AI flagged similar patterns in two other voids, each showing signs of synchronized motion, as though communicating across billions of light years. Whether it's a natural phenomenon or the first sign of a presence beyond our understanding, one thing is certain: the James Webb Telescope, aided by machine intelligence, has glimpsed something in the darkness that challenges the very limits of human imagination. For now, NASA's AI has only one label for it: unknown entity. But whatever it is, it's watching from the void, and it's real. In late 2024, while scanning a dense cluster of galaxies near the constellation Fornax, the James Webb Space Telescope detected something so bizarre that even seasoned cosmologists refused to believe it at first. Galaxies moving backward in time, Webb's instruments recorded light patterns from several ancient galaxies that didn't simply redshift as expected, the stretching of light as the universe expands. Instead, their spectra appeared reversed, as if time itself were running backward in that region of space. The motions of stars, the growth of dust lanes, even the expansion of the galaxies themselves looked inverted, like watching a cosmic movie played in reverse. At first, the team thought it must be an error, perhaps a calibration glitch or a software misinterpretation. But after months of painstaking verification and cross-checking with other observatories, the phenomenon remained. Something near Fornax wasn't just bending space, it was folding time. Some physicists think Webb may have captured the signature of a time fold, a region where the normal flow of space-time loops back on itself, like a wrinkle in the cosmic fabric. Others whisper about something even stranger, a simulation glitch. In this theory, the universe behaves like a vast computational system, and what Webb saw was a rare moment when the code faltered, briefly revealing its underlying structure. If true, it would be the first evidence that time is not a constant stream but a manipulable dimension, one that can reverse, loop, or overlap under extreme conditions. This could explain why the galaxies looked both ancient and newborn at the same time, their stars evolving in reverse, as if rewinding cosmic history. The implications are staggering. If time can fold back on itself naturally, then the universe may host regions where the past and future coexist, places where cause and effect lose meaning. And if what Webb saw really is a glitch in some grand simulation, it would mean everything we see, every star, Every planet, even ourselves, could be part of something far larger and more intentional than we can comprehend. For now, NASA's public statements are cautious. They call it an unusual temporal signature and say further study is needed. But among those who've seen the raw data, a quiet unease lingers. The Fornax anomaly isn't just an oddity. It's a direct challenge to the very foundations of reality, space, time, and everything we think we know about how the universe works. As Webb continues to stare deeper into that strange region of sky, one question echoes louder than all the rest. If time can run backward there, what does that mean for here? As the James Webb Space Telescope continues to peer into the farthest reaches of the cosmos, one thing becomes clear. It hasn't merely advanced human knowledge, it has redefined the very rules of science. From the first glimmers of dark stars to the ocean-covered exoplanets, from organic molecules formed 12 billion years ago to galaxies that should not exist. Webb's discoveries challenge every assumption we've ever held about the universe. We've seen hints of parallel realities in mirror galaxies, pulses from dying stars that seem almost like messages, and gravitational spirals inside cosmic voids that defy explanation. We've even glimpsed regions where time itself appears to reverse, turning our understanding of cause and effect on its head. Each of these anomalies is more than just a scientific curiosity. It's a reminder that the cosmos is far stranger, far more complex, and far more mysterious than we ever imagined. For scientists, this is both exhilarating and terrifying. Every theory we have about the origin, evolution, and mechanics of the universe must now be re-examined. Models that seemed robust just months ago are now incomplete, perhaps even fundamentally flawed. The James Webb Telescope is forcing humanity to confront an uncomfortable truth. We are only scratching the surface of reality, but there's wonder in that uncertainty. Every photon Webb captures, every gravitational ripple it detects, and every pattern flagged by AI opens a door to questions we've never dared ask. Could life be inevitable across the cosmos? Could other universes exist alongside our own? Could the universe itself be trying to communicate in ways we are only beginning to perceive? The telescope was built to see farther than we've ever seen, and in doing so, it has expanded not only our vision, but our imagination. What comes next may surpass anything we can predict. The universe is no longer a silent backdrop. It is an active, dynamic, and infinitely mysterious entity, inviting us to explore, question, and marvel. James Webb hasn't just captured light from the past, it has illuminated the edge of understanding, showing us that the cosmos is a place where science meets wonder, mystery, and the profound possibility that reality is more extraordinary than we ever dared believe. The journey is just beginning, and if these first discoveries are any indication, the universe still has secrets that could break reality itself. If you found this journey through hidden science, cosmic secrets, and potential alien infrastructure as mind-blowing as we did, make sure to subscribe and hit the notification bell. Don't miss future explorations into the universe's deepest mysteries, because some secrets are just waiting to be uncovered.